In the previous video, we saw that Saudi Arabia of wind can't be obtained by increasing generation capacity while throwing away excess. If we could use the excess by storing it somehow, perhaps it might be. How much energy are we talking about? That Loganberry stain around the UK is ESMAP's maximum wind resource depiction. The UK has a lot of shore, strong winds, and hence a lot of offshore wind potential. Common estimates of UK offshore wind potential are around 2,000 gigawatts. The 4 times 80 gigawatts promised is less than 5% of UK's potential. The 5-day curtailment example from the previous video totaled 120 gigawatt hours. Rationally, 4 times capacity might increase only excess, resulting in an excess of 7,200 gigawatt hours for the same episode. Additional renewable generating capacity in a curtailment episode can only be turned off, unless we can find somewhere else for it to go. Grid-connected storage is the obvious answer. How much have we got? Pumped hydro, such as Dynawig, is a favourite example. It can take 9 gigawatt hours of energy in the form of water pumped from a lower pond up to an upper pond. On-grid battery storage is the new kid in town. We added Europe's largest battery storage project last year. The owner has more projects. This project took them to a total of 3 gigawatt hours. Pumped hydro and batteries aren't really storage in the traditional sense. These are valuable components helping to optimise and stabilise the UK grid. They store and return energy on a scale of hours. To benefit from May's huge windfall, we'd need storage of up to months and perhaps even longer, and thousands of times larger. The Royal Society's Large-Scale Electricity Storage report said the same thing. Pumped hydro and batteries are thousands of times too small. The Royal Society picked hydrogen stored in new caverns to illustrate a plan based on producing gas with excess renewable electricity, which could be used potentially much later in power stations to generate electricity in times of slack renewable electricity generation. I think we should do it with renewably synthesized natural gas, sometimes called ENG or e-methane, as we already have the power stations, storage, transmission network, and industrial and consumer appliances. How much energy could we store with, for example, Centrica's Rough gas storage? Let's do some numbers. Rough is an old gas field off the east coast which has been used as a gas store for decades. Oil and gas use some arcane units. The 54 billion cubic feet here is about 1.5 billion cubic meters. Methane has a thermal energy potential of about 10 kilowatt hours per cubic meter, which puts Rough at roughly 15 terawatt hours or 15,000 gigawatt hours of energy storage. There's our 1,000 times larger store. Rough doesn't hold electricity, it holds gas. When the UK needs to burn gas to generate electricity, we do it in CCGT, combined cycle gas turbines, with an efficiency of something over 50%. The rest of the energy is lost as heat. The storage conversion from renewable electricity would similarly lose some energy. CCGT efficiency in UK is well over 50%, so 50% gas to electricity errs on the side of critics. I chose an efficiency of 50% for renewable energy to gas for the other half of the round trip from a note somewhere online that suggested a cycle efficiency of electricity-methane electricity of 25%. This is illustration, not science, so please just eat the dodgy number for now. The code represents the state of the Rough storage in gigawatts internally. I should have written divided by 1,000,000 there. I start with Rough at 30% capacity to avoid likely silly results for a broken Britain that had completely run out of gas to the point of flame out. Obviously, one attraction of using natural gas is that synthesized commodity would be chemically identical to fossil origin gas. New synthesis plants would use our existing pipeline store power station appliance infrastructure, and every litre of renewable gas would directly replace a litre of fossils. Nobody would notice the change. Back to not GridWatch again. This time Overgen doesn't appear in the data. It's used to synthesize ENG into Rough's store. Electricity generated from gas while Rough still has gas is blue and displaces the brown of fossil gas in the same power stations. Rough's fill state in grey is represented in terawatt hours. When Rough empties and the brown of fossil gas electricity generation reappears, imagine we're importing fossil gas via e.g. pipeline. A single day or two of electricity consumption that needs gas power stations is easily accommodated by Rough's store. 9 days of low renewables may, however, required almost all of Rough's storage to be burned in power stations. The Today chart shows 220 gigawatt hours of ENG burned to support the electricity grid. Half a day's electricity is 100 times the size of a pumped hydro dam or a battery project. The previous day required 660 gigawatt hours of ENG due to weak solar and wind. Our model cushion of ENG in Rough isn't replenished with the raw data because there's no overgen, so it lasts only 2 weeks in April before fossil gas must replace it. Let's try 2 times. With 2 times wind power, ENG in Rough lasts a little longer before being depleted and fossil gas being needed again. Note the year charts. In both cases, the UK is back on fossil gas electricity generation before the end of January. At 3 times, we can see April depleted Rough's cushion, but no fossil gas was burned. This year, having little turn-of-the-year wind, lasted on ENG until the end of January. Last year had decent wind and lasted until March before fossil gas was needed. At the currently promised 4 times, all the charts appear to suggest no fossil gas would be needed. 2025 wasn't a very windy year, so by the time May came along, more than 80% of Rough's ENG cushion had been consumed. Compare this with 2024's chart, when Rough finished with twice as much ENG as it started. This is all I set out to do, to show the potential of the promised 4 times expansion of renewable capacity without and with an adequate storage element. Thank you for watching and for listening.